Good evening, ladies and gentlemen. I found what was categorized as a difficult SAT uh, scholastic. I think that stands for Scholastic Aptitude Test, and it's the entrance exam in a lot of the United States colleges. This was categorized as difficult problem. Now, they use a different word. I think they use the word solutions. And the words solutions and roots are synonymous in this context. A root is any value that makes an expression equal to zero in the unknown. Okay, root solutions mean the same thing. Okay, now, so this looks awful nasty, but just keep in mind it's in quadratic form. X squared's right here, X is here, and think of this as just a constant. Okay, now down here, just to make it give you an idea of the motivation for this, which is actually pretty easy once you trust it. R1 and R2, anytime R1 and R2 are roots, I'm just using that notation to distinguish between A and B here. But this is called R sub 1, this is called R sub 2. And roots correspond to factors. If something is a root, it's a factor. Like if 3 is a root or a solution, then x minus 3 is guaranteed to be a factor, because if you put 3 into x minus 3, you get 0. Okay. Now, when you expand this out, the negative sum of the roots present as the coefficient of x. And you guys can just expand this out on your own to verify that if you want. But when you expand this out, these two guys, R1, R2, their sum are the negative coefficient of x. Okay. Now, that turns out to be quite important right here, because we can take our original equation, our given equation right here, and we can divide through by this coefficient, if you want to call it that, 10b plus 6a. That's what we did going from this step to this step. Now, why do we do something silly like that? Because you see, this x squared, we want this to happen for us so we can do a comparison of coefficients. Okay, folks, that's why I wanted to rewrite this like this. Notice when you divide by 0, you get a free lunch here. You divided the 10b plus 6a into 0. Of course, that's 0 back, right? But all we're interested in is this object right here, because we can equate it. See, this is the object that's in front of x, and then this is also the object that is in front of x, so we can equate those things. But remember, we're told what that is equal to, okay? It's equal to this right here. Okay, it's equal to, in other words, excuse me, we're told that this guy is equal to 21a minus 35b. That's given to us. Okay, that's the sum of the roots. It's given to us. But we've seen that this is also the sum of the roots minus some of the roots. All right, it's a little confusing, but once you get used to just flipping the signs on it, it's fairly easy. Okay, so what we end up with after a little bit of algebra is just that k is equal to this. See, we get k times all of this is equal to this, but then we divide through by that and we get k algebraically isolated. Okay, we get k all by itself, and then everything factors rather nicely here. If you take a look, you can see how every one of these factors cancel. 3a plus 5b cancels with 5b plus 3a, the same thing. It's commutative property. And of course, 3a minus 5b and 3a minus 5b cancel. And you'll see that you just have all of this cancels, right? So you have 1 over negative 7 times 2. Let me write that parenthetically, all right? Okay, which is equal to minus 1 over 14. Is equal to k, which is what I got for the answer. Okay. Pretty sure this is correct, folks. The idea is okay. Sometimes you make mistakes in factoring. I don't know if they give partial credit on SAT. I think it's like multiple choice, so you know partial credit. But anyway, this looks rather complicated initially, but if you trust what I did right here, this is the form I got to, just in a generic sense. And that means that we just have x squared. This is called monic. It's a monic expression. And so that's why I wanted to rewrite our given expression in this monic fashion, so we we could equate exponents. We could equate, we equated this with minus r1 plus r2, but we were also given that the sum of the roots was this, you see. And again, it's simple enough. It's just a lot of letters flying around, but this is minus the sum of the roots or the solutions appear as the coefficient of x. We have this also as our coefficient of x, and then they actually give it to you, the sum of the solutions or the roots is this form right here. So it's a little confusing, but in a way it's easier than other solutions I've seen presented if you trust this methodology here. It's really pretty quick and dirty if you just kind of trust the steps we went through right up here. So I hope that made sense. Let me know if there's anything I can do to make it clear. Okay, so let's come back up here and write this. K is equal to minus 1/14. Minus 1/14, folks. Did I write it legibly down here? I did. K is equal to minus 1/14. Okay, good night.